Let's start by looking at your protractor. All protractors should have some sort of center point. Sometimes it's crosshair, sometimes there's an actual opening there. Ours are going to look like this. Notice that there are two sets of numbers around the outside. This one goes from 0 to 180 this way. This one goes from 0 to 180 this way. So that's something you'll want to pay attention to. Let's start with our first angle. It looks like an acute angle, angle A here. And so what we're going to do is we're going to take our protractor. Remember that that center part always starts on the vertex. So you're going to want to put point A right at that center part. Next, you're going to want to line up one of these zero lines, and it doesn't matter which one. I'll use this one this time. You're going to want to line up a zero line with one of the rays on the angle. So step one, I have the vertex at the center. Step two, I have one of the rays lined up with 0. And step 3 is to measure. So did you notice that I was using this 0, sort of that inside 0? So when I count, I'm going to be using these bottom numbers. So this opens 10 degrees, 20 degrees, 30 degrees, somewhere between 30 and 40 degrees. And I can sort of follow these little tick marks up here. To me, it looks like it's a little past 135, maybe 1 degree past 35. So I'm going to call this 36 degrees. And I want you to be that accurate. I want you to be as accurate as possible. 36 degrees. Now this one's an obtuse angle, so I'm expecting my answer to be bigger than 90 degrees, right? Step one, we're going to line up the vertex at the center of the protractor. I could either turn my protractor so that this 0 is hitting that ray, or this 0 hitting that ray. Totally up to you. I think I'll go this way this time. So I'm going to have my center at the vertex B. I've got 0 lined up with that ray. And now, since I'm using those outside numbers, I'm going to follow 10, 20, 30, 40, 50, and I know that I was expecting it to be bigger than 90. It looks like it goes just a little past 100. What do you think that looks like? 101, 102? I'll go 102 this time. 102 degrees for this angle. And that's how you could label it on the picture. Number 3 is asking us to do something a little bit differently. Number 3 asks us to bisect the angle. I wonder if you can figure out what that means, but let's start by measuring it. Got my vertex at the center of the protractor. I've got one ray lined up at 0, and I'm going to follow the 0, which is the outside again. And to me, it looks like that is going to about 120 degrees. Do you see that? 120 degrees. What does it mean to bisect an angle? It means to cut it in half, and not just in half, but in half, into two congruent angles. So I'm going to take 120 divided by 2, and that's 60 degrees. So I'm going to line up my protractor again, same way. And I'm just going to put a little dot out here at 0, 10, 20, 30, 40, 50, 60 degrees. Once I have that little dot out there, I'll be able to connect vertex C out to that dot. And what I've done is I've split that angle into two congruent angles. This one's going to be a 60 degree angle here, and this one's a 60 degree angle here. And there's not really a way to go tick tick on congruent angles, so what I'm going to do is I'm going to go swoop, swoop. And so that's the notation that tells us that those are congruent angles, as if you see the same type of swoop on each angle. Number 4, the diagram is a lot more complicated, right? And that's because I wanted to practice. There's so many different angles that we can't just call one of these angles angle D. We have to use 3 letters. So the first one asks for angle EDF. EDF, which would be this angle right here. So on all of these, it looks like the vertex is at point D, so I'm going to line up my protractor with the center at point D, the vertex. I'm going to make sure 0 is lined up on one of the rays. Nice and accurate. And I'm expecting this to be an acute angle, so I'm following those smaller numbers just to, what does it look like? Between 20 and 30. I think I'm going to go with 27 this time. Where's angle FDH, the measure of angle FDH? So that's this sort of larger angle, right? So we're going to have to turn our protractor. So point D on here. Now if I line up this ray, that's not going to work. I need to sort of turn my protractor so that the 0 is lined up with one of the rays. And since the 0 is the bottom number this time, I'm going to follow the bottom numbers. And so this looks like, if I do that entire angle, it looks like it just went barely past 90. I think I'm going to call it 91 degrees, almost a right angle. And then the last one is HDE, angle HDE. That's this enormous, this entire one, right? So again, whichever side you line up with the 0, I could line up point H over here on the 0, or I could line up point E over here on the 0. Totally your choice. Making sure D is at the center, point H I'm going to use, and I'm going to follow the outside one. 0, 90, and what do I have? A little past 110. Oh, I'm going to just jiggle this around so I can see if I can get right on. To me, it's looking like 110, 115, 118 maybe? 118 degrees. So that's your little lesson in how to use a protractor to measure angles.